Okay, so we will get started and we'll go through step by step on just a few things because I thought it would be a lot better for everyone, especially that hasn't really done a lot of HEC RAS, if you just kind of got in the program and did a few of these exercises in order to feel more comfortable with it. So I will pull up, make sure you have the spreadsheet that was in that zip folder open, and then open up HEC RAS version 5.0.7 and open the TRJ file that was also in the folder. Does everyone have that so far?
Jeez. Nope. 1 sec to navigate. See, how do I get back? C drive. How do I get to my desktop? C drive.
That's why I usually don't put it on my desktop, but if you did do that, it would be under C users, your name.
Never mind, I'm an old school. I'll just drag it in because you can do that
desktop.
with right. You can just drag it in with
I do not know.
Yeah, you can just drag it in. Are you sharing your screen?
Can y'all see my screen? Am I sharing yet?
Yeah, I dragged it in. It's faster.
Okay. So has everyone got the file open?
For some reason, my spreadsheet is not wanting to open. But
Okay,
I'll get there.
But you got the HEC RAS file open, right?
Yeah.
Okay. Well, we'll start with that. So in HEC RAS, so let's go to the plan navigator, which is going to be this running man. And let's click on that one. And let's open up the corrected effective. So go File, Open Plan, and let's open the corrected effective existing plan. And that contains the corrected effective existing geometry and the corrected effective existing steady flow file. So if we then click on our geometry editor, and y'all just call me out if I go too fast because it'll be hard to catch up if I lose y'all. So don't hesitate to call me out, but I'm gonna try to go pretty slow and methodically. So once you're there, let's click on this view edit geometric data. And this will pop up the geometric data for this file. What we were preparing in our last couple sessions has already been brought in as far as the cross sections and your bank lines and your flow paths that get the reach length. So this is getting into more of the nitty gritty of HEC RAS. And then I've started some of the culverts in here, but we're going to make some modifications to those. So let's just, for the heck of it, click on the cross section, and that will allow you to see the cross section data that is in the model. And you can use these arrows. I'm not really going to do much yet, but you can use these arrows to navigate. If we look at specific cross sections in this one, like here, we see we've added some notes in there, and that's in the description. So that's good to sometimes do to say why this cross section's there. This is upstream of Wood Springs Road, and this is a new cross section that we added to the corrected effective. It wasn't in the original. You don't have to get carried away with that kind of stuff, but it's there if you want to add some notes to clarify things about cross sections. Okay, so the first thing, let's close out these cross sections, and now let's open up the bridge culvert editor. and we see, go to the one at River Station 1325. If another one pops up, just use these arrows to navigate, and go to the one at Wood Springs Road. And now I'm gonna open the deck and roadway editor. And the last time on cross sections, we talked about the different cross sections you have in the model, how you have one upstream of the bridge and then one a little bit farther where most of the contraction or expansion has already taken place. I want to briefly touch on what these numbers are here, or what they approximately should be. So this distance in your deck roadway editor, did I skip that step? I didn't say that out loud. Go to your deck roadway editor here. And if you see the distance and the width, these have to be entered by the user. And that should be entered as, this is your distance to the upstream roadway face. And then this is the width of the roadway. And usually for culverts, usually it's the same. Sometimes you consider the abutment slope and you make it a little bit different, but usually I'm going to enter these the same as the width of the actual culvert. So in a DGM file, what that would look like is you have your cross sections, your distance from your distance there represents your, this is our upstream cross section. So it's going to be approximately this distance here. So it's 5 feet. I must have measured it last time a little bit differently and have 4 feet in there.
The distance along the stream center line, not necessarily perpendicular.
Correct, yes. That is 5 feet. Let's go ahead and change that because that's a little bit 1 foot off of that many. So let's make that 5 feet. Now I'll show you something in our spreadsheet in a second, but I'll just make the change there. And then the width we're going to get by just measuring across the culvert and the cross sections. And that's about 42 feet. No reason to use decimals and this type of stuff. We're not that precise, but it wouldn't be wrong if you did. It's not that wrong, but I just try to use whole numbers on things like this. So 42 feet. And what HEC RAS does is it looks at, just so you get an idea, it looks at your cross section upstream. And it knows the total length is this channel length here, 55. And so it does kind of a calculation in how wide it draws this structure. So just for fun, I'm going to make that, go back to the deck and roadway editor. We know it should be 42. If I were to make that 100, it would look goofy in my plan. And so, and if I were, because it thinks it's farther than the distance between the cross sections. And if I were to make it 5, it would again look kind of off. So it should be, what you should see should be somewhat of a representation of what's actually in the field. So that's a good way of checking your model. So I'm going to enter the 42 feet here and then hit OK and go back to the deck roadway. Okay. And so we need to keep moving. Another thing we might do, this is a culvert. We're going to enter in a whole bridge after this, but I wanted to get y'all some feel of what the culvert editor looks like. So if we have a section like this, these are the sections we cut upstream and downstream. What we often do is modify these to show them being cut out to where the culvert is here. And so I like to keep everything dealing with bridges, or most of the items dealing with bridges, in a spreadsheet. So let's pull that open when you get a chance. And we'll do a little back and forth between it. You'll see why after looking a little bit why it's useful to have this stuff here. So let's go in the spreadsheet, go to your Wood Springs Road corrected effective tab. And what HEC RAS does is it uses these cross sections, unless you tell it otherwise, as the upstream and immediately upstream and downstream of the culvert. But a lot of times I just don't like seeing that. I don't know if it'll affect how the model runs. I think it probably won't, from past experiments, that it won't really do anything. But it's just kind of, we know that by the time you get to the culvert, the ground is cut out to the culvert edge usually, other than sedimentation, which I usually ignore if we're comparing existing to proposed, because I want to assume existing was as it's meant to be and not how it actually is. So what we have all this stuff already in the spreadsheet, and we've got this spreadsheet set up for easy building of things like bridge structures. So what we have in here is the low chord and high chord data is over here, and then we have these upstream downstream sections down here, which represent these sections that you're seeing here, and then the roadway editor data is this stuff that you're seeing up here in the top gray. So I want to just click on these bottom corners real quick and do some modification to that upstream data. So I see this 1272.50. I'm going to write this down. 1272.50, 420.71. And then I see this 1304.50, 420.71. Now I'm going to go back to the data in the spreadsheet and look at this upstream section. And I've got this spreadsheet set up to where it displays stuff pretty nicely. Sometimes the links break and you have to mess with it a little bit, but overall it's helpful to me. So let's go down in our data and look for 1272. So somewhere in this area is our culvert. So I'm going to take that and I'm just going to modify it a little bit and go 1272.5 and 420.71. And y'all can do this too in the spreadsheet. Have you found that station? And then you can, and then this last one before, this last one was 1304.5 on the other end of the culvert. So I'm just going to manually type that in and get rid of the rest of this data between here. So I'm going to get rid of this stuff. And then take this data and copy it back up. And scroll down enough to where you copy over the remaining of this data that you will have left. So you put that up. And then your upstream in the spreadsheet is going to look something cleaner like that. So I can take this data, all three of it, all three of these rows. The one includes the Manning's Inn. I'll show you something on how to get that if you were doing it at the as the very first time. But now let's go back into HEC RAS and open up this, go to options, internal bridge cross sections. And I'm going to overwrite what's there because I've kind of tweaked that cross section. And I'm going to say, okay. Has everyone stayed up with me to this step? No? Elise? Where y'all at? Can't hear you. You're on mute, Elise.
Sorry. I got changing the inverts for the culvert. Totally understand that. Know what you're doing there. But one thing I have a question is why do we have the two separate columns? Why do we have everything on the left plus it copied down on the right?
Here.
Yes.
So these are your roadway deck information, and this is the upstream and downstream sections to that bridge. So the roadway deck is what you see in gray, like the, and so that's
Okay.
usually cut by doing a cross section in the middle, which I plan on one of the other days we'll do that. But and then the sections are your upstream, the one just upstream of this bridge culvert,
Gotcha.
and this one is just downstream of it. So
And you pulled it down because that's approximately where the station is, or you just randomly put it there?
I just pulled it down. I went up to this data in here, and I'm about to do it for the downstream size and basically take all this out and have it come down to that corner and that corner.
No, I got that. I guess in the spreadsheet, the layout, did you just put it down there, or is it there specifically for a reason down there?
Put it down
there. Like, is that where the station starts physically on the plan view, or is it just down here because?
Oh, as far as down versus being up here in the spreadsheet somewhere?
Yes.
Oh, yes. Yes, it's just dragged over. It's different sets of data, and I might have other stuff. This was not a bridge, so there's more to do for a bridge. So actually, I will get to it on the next thing we do today.
Okay,
you'll see
so
it
just
a little
no,
different
that
format,
space
but
is
it's
there
just
for a reason.
yeah. This
Okay.
is yeah.
Okay.
It's just a place. I've got this data dragged over here, but it doesn't really signify anything as to where it falls over here.
Okay, because it was pretty close to
Yeah.
the 1270, so I thought maybe for a reason.
No.
Okay, so I followed you up to that. I changed my station and invert for those two, the beginning and end of the culvert, but then I lost you when you were copying stuff and moving stuff. Yeah, I lost you after that.
Okay, so you got it in the spreadsheet. Your Excel is up to date.
I deleted out everything in between those station numbers and just put the two.
Okay.
But then you were copying something, and that's where I lost you.
So yeah, now take this data, now that you've modified it, it should look closer to this in your graph, to where it's kind of coming down to the sides of the culvert.
Oh yeah.
So now you can take that data and copy it, and then you can go into your bridge deck editor. I'm gonna close some of these pop-ups. Click on your bridge culvert and go to options, internal bridge cross sections, and copy that over your upstream stuff. And then on the downstream side, we're going to do the same thing. So I'm just going to write down these numbers so I can find it in the data real quick. So 1295.50, I want to be at 420.66. And I want that to go all the way to 1328.50, 420.66. So I'm gonna go, I've stored it in a spreadsheet. Makes my life a little bit easier on some things, especially what we're gonna do for the bridge. So what do we say, 1295.50? So I'm looking for that. Should be around here, 12. So what I can do is take this first one that's past it and say 1295.50 and make that 420.66. And then go all the way down to the next one would be 1328.50 was my other point. So 13, how about that one? Close enough. Change that to 1328.50 and 420.66. So now I'm gonna yellow that one and yellow that one. So now I'm gonna take all this stuff and actually I did what I said not to. I'm gonna go down a little bit farther so I don't have to delete stuff afterwards. Oops. I think that last stuff is no bueno.
We
I don't
can
know what
leave
that.
that.
Yeah, I think that might have been leftover stuff. Okay, so now it looks cleaner in this graph, so I'm going to copy it over. So I'm going to grab all this and go back here, options, internal bridge cross sections, and copy that in there. Say okay, and that looks pretty good. So that's just one thing. I really wanted to show y'all more of the entries here, and then the same. So we changed this to 5 and 42. It'll be the same type of information here. Sometimes it'll be a little different if you have like the culvert just sticking out of the road and you want to model it a little different, but usually it's going to be the same. Usually we just assume the roadway width and the culvert width is the same. So that's there. And the other thing from the spreadsheet, so I've got what I do is we know what size from survey it is. And another good reason to have it in the spreadsheet is now I've got this cross section in there. So before I have to play within the model, I could just measure and where the center of this culvert's going to be. And you do that knowing that your cross sections are cut from left to right. So this is 0 here. So you would just measure along this to the middle of it, get that middle station. And then if I know I'm talking about a 10x6, the space in between them, you can kind of calculate what that's approximately going to be based on how thick the culvert is and how much spacing we usually have. And then you can get all your centerline stations. And where you would enter that in for a culvert is in this culvert data. So you tell what size it is, and then you give the barrels upstream and downstream centerline station. and that's what causes them to pop up where you want. So it's nice to be able to see it in the spreadsheet, make sure it looks about right. Now, if I come back later and like, oh, well, actually it's 8 inches thick and the spacing is a little different, that doesn't really matter on what we're doing here. So you don't need to get too carried away with how accurate your spacings are and stuff. We want to get it approximately looking like what we have in our design, but they're not designing off of what we prepare HEC RAS. So we want to get the number of barrels right, where they are right, how long they are, what their flow lines are, stuff like that. But this stuff, we want it to look right visually, but you don't necessarily need it to be to the nearest inch. So the next exercise, okay, this took a little bit longer than I was hoping, but now let's go to the next one. And I think this stuff is set up, and I think it'll be a really good exercise to give y'all a feel for what gets entered in for the bridge editors. So if you go to the next bridge section down, this is 1225. It's called I-20 Main Lanes Bridge. Do y'all have that open? Got it yet? Thumbs up?
Got it.
Okay. So let's go to the tab in the spreadsheet for this one. So we're doing, this one is for an existing model, existing conditions model. We're calling it corrected effective, but it's basically our existing conditions. So if you go to this tab, I-20 main lanes corrected effective. And what we are going to have a lot of times is a record drawing showing what was built and what kind of bridge we have. So we start with that. And this one is very hard to read, and I just know from the previous model that the water surface elevation is going to be somewhere around where my cursor is now, way lower than the low chord. So I'm not going to stress too much about the details of the low chord, but what I am going to gather from this bridge is, and try to incorporate accurately into our model, is that it's a 176-foot span. And yes, it's hard for me to tell exactly what type of beams, and it also just doesn't matter a whole lot, so I didn't stress too much about that. So in the spreadsheet, I made one up, but this 176-foot span has four spans, 3 columns and 4 spans. The first one's 38 foot, the second 2 are 50 foot, and the third is 38 foot. So I have typed that into the spreadsheet here. So you'd want to kind of document what you're doing. This helps the reviewer see that you put some thought into modeling what is actually out there, because it would be very hard to check just a model without. It's a lot easier to check a spreadsheet where things are documented in there. So we've got that. What else? We've got these. We've got this spreadsheet set up to center the columns and everything, but it's not in the correct location the way it is now. So we're going to have to do some of that math. But we got the high chord into the bridge. That's been done for you, so that hopefully this will be a little bit of a quicker and we can just get this figured out. So what we would do here is we need to figure out where the center of this bridge is to start. And I have it written down there, but I'll show you all where we get that from. So I'm going to go to the cross section upstream of it and measure out. Y'all don't have the DGN, and that's okay. I just want to show y'all where it would come from. So I'm going to measure from this end of the cross section that's upstream of it to the approximate center of the bridge, which is, I have it marked as about right there. And that's going to be about 1286 feet. And so I've done that on the downstream side too, and have that calculated out. So knowing that, we could, and then we know our span data from the as-built. So we could say 1286 is the center line station. So to calculate the left abutment of a 176-foot bridge, I would calculate it from that center station minus 176 over 2. So I'd get that station. And then I could get each of my pier center lines based on the span. So the first span is 38 feet. So I've got that as an equation in my spreadsheet. And then I've got the next one being 50 feet, 50 feet, and 38 feet for the last span. You all follow that?
Yep.
So the spreadsheet, just to document our work, I'm going to put these stations in. So the first pier, this is for the piers. I've got this area for the piers. So upstream, we've got pier 1 at 1236 upstream. And then on the downstream, this should say downstream. It's 632, this number here. So if I enter both of these in, if you enter those in here, and then you enter in 1236, and then 1286 for the second one. And then 1336 for the third. So those, you see the graph starts to come together. There's a little bit of a lag in Excel for some reason, but then on the downstream side, we got 682 as the center and 682 for the pier 2, and the pier going to be at pier 3, 732 is what we calculated. 732, 732. So this one is kind of lagging, but if I change a number, I bet it'll come back. So the other thing we haven't done, but so we got those figured out. So those could be entered into RAS, and we'll show you how to do that. The other thing is you need a low chord. So the low chord is based on, you think of how wide your bridge is. You got that 176-foot bridge. So your abutment is going to be this, the center minus 176 over 2 on one side, and then the center plus, well, this is calculated, it should come out to be the same, but the center plus 176 over 2 on the other side. So basically these stations for the abutment 1198, 1374. Another, you'll see why the Excel comes in handy here. So I want between 1198, which is somewhere about here, so somewhere in between there is going to be 1198, right? 1198 is my left abutment. And at that station, we have an opening. And so that would be based on how thick your structure is, which is going to include your roadway deck, something called the haunch, which is just what the roadway deck sits on before it's right on top of the girder, and then your girder and all that. So I've just assumed a girder type, which is good enough for this model. because it's so high above the water surface elevation. So your low chord is going to be your high chord minus this in this case. So you're doing a lot of geometry to get these things to work. But it should have been this minus this. And this will be a F4 $sign to lock that to where it's always referring to that. And then let's see, we are gonna want to, so we got 1198. So we see we just added this point here, but I made up that point. Let me add one more. So let me, for the other side. So I'm gonna copy this down. I might, and then enter that right abutment station. That's also gonna have a low chord. So I'm gonna enter that in at 1374. And I'm gonna pull that equation down. Now we see a low chord pop in the graph. That shows that we have a low chord in the bridge. What I want y'all to realize is these 2 points didn't exist and before it was going there. So I want to kind of make this line look straight between those other points. And that's why it's good to have the spreadsheet so I can kind of just do a little bit of, I could do the interpolation formula or something. Maybe I normally would if there was a longer profile, but just to get it visually looking straight is good enough for this. 440. So I put 440.13 or something. Oh, that's wrong. 444.13. Maybe a little higher. That's going to be good enough. So if y'all have that in there, now we can go. Let's go, since we're running out of time, it would be the same thing for the downstream end. But let's go ahead and take this data. Did everyone follow me up to there? That's probably the most complex thing we did today, but did that make sense?
So, so you're just putting your low chord and you're really just estimating it. You don't have the true elevations because what, the bridge data is so old.
Yeah, it's so old. If you have a new bridge and you're gonna
Or
have
proposed.
what type of structure it is, and you can calculate with pretty good accuracy how thick the depth is. But it is also, our water is going to be up in here, so it's not that important other than I want to show that I'm accurately modeling what's out there. And so, yeah, we know how wide the bridge is. So if I did this 1374 minus 1198, that should equal the width of our bridge. And it's 176, this minus this, which is what we're trying to model. So we're taking these span lengths and total bridge opening width and imposing them on the upstream cross section that we have, and we should get up something that looks somewhat close to what's actually out there. So to enter that, if y'all have that, do you have this in your spreadsheet? Were you able to keep up with that?
Yep.
Okay, so if you take this data, your upstream deck roadway, and let's go into your deck and roadway editor, and we're going to replace what's there in the upstream side. And it should come out looking like that now.
We need to get all 3 columns.
Yes, and so the columns would be another part. So we'd of course have to do the downstream side too. So in our spreadsheet, we have this entered in a good form to be able to take that and put it into HEC RAS. So let's go to your peer editor right here. I'm going to close this Culvert editor. I don't need it for a bridge. And we've got 3 peers and we're going to enter each one. I'm going to try to move this stuff to where I can see it. So the first one we got, these are 3 feet wide. You would get that from survey or field measurements or the previous model if you don't have anything else. So, and then the elevation, you basically want it to, you want to give it a lower elevation that's lower than where it would be in the cross section and an upper elevation between the low chord and high chord. So you give it 2 elevations. So I give it a center line upstream here, which would be what I have here, 1236. And center line downstream of, that would be this station, 632. We're only going to see it pop into the upstream view because the downstream is still all covered. So then I'm going to say 414 to 440 as a try. And downstream, I have 415 to 440 there. So we'll see. That can just be a trial and error thing. Or, I mean, you can basically see what it needs to be looking at it closely.
Why are we only putting in 2 of the 3 peers? Well, I'm missing that explanation.
We're going to put in 3. Oh, here, this is putting in 1 peer. With this editor, this is peer 1.
Oh.
Okay. And you're giving it the upstream information, center line upstream. So that's this station. And the center line downstream is this station. And then you're giving it the peer width and its bottom and top elevations that you want it to show up at. So we're going to do that. And then we're going to add another one. And this one's going to be 1286, 682. And it's going to be 414, 440 again, or the width is going to be 3. 414, 440. You could probably do 415 or 414, it wouldn't matter, but over here I have 415 written. And then as you add them in, they show up here. Oh, they do show up down there, even though I haven't opened up the section yet. So if I zoom into that, I could see actually I would want to go a little higher. So I could go back to my peer and be like 441.
What if my peers aren't showing up? You did that. You did that.
Did you hit apply?
I hit OK.
Hit OK. You have the center line entered.
Yep.
Upstream, downstream, the width.
Yep.
The elevation.
Yep.
And then I would do my last one, of course. Did you do all 3 yet, Delise?
No. And then I just did add, which is what you're supposed to do. Add new peer, right?
Yes. It doesn't show up until you hit OK.
I hit OK.
And then you click on your thing again and it doesn't show up still?
Oh, there it goes. I zoomed in and it didn't show up. Like, really? I have to click on it?
So I'm going to add the 3rd peer here. Okay, 12, and that's going to be at 1336. Oh no, I always forget what we're entering. 3, 3, 3, 3, 414, 441, 414, 441. That's good enough. 1336 upstream and 732 downstream. Okay. Did everyone get that? Did yours come in right?
Yep.
Okay. The other thing in the spreadsheet, and this may, do I have this set up? I have this area over here to help calculate what the sloping abutments will be. This is going to relate to 1198. Your station will be, you're usually going to have the sloping abutments at where your bridge opening is. Basically, it's like the slope paving that's there, and we usually want to enter that in. So the left side, we have 1198 for the abutment, and the right side, 1374. And we can dig into this more some other time, but just for now, let's scroll over to this and copy this data for your left abutments or your upstream abutments and paste it over here. Paste values. And then let's go in here.
Wait,
and in your
I think
Yeah,
I lost
wait.
something.
Yeah, me too.
what's
That
that?
information. What did you paste it there?
Yeah, where did you get that info from?
This I have as the sloping.
Oh, it's
I
further
don't know if we have
over.
time to explain where all this comes from, but it calculates your. It helps you enter some information to calculate your
Oh, no,
sloping abutments.
Oh, it's
That's good. I didn't see that part. It was too far over.
no, I see
So
where
you-
that is. I thought you copied something from somewhere else and then
I'll
pasted there.
explain
So I
it.
was like, what?
I will explain it briefly though. It's basically set up to, because you have in your drawing, we got these abutments here. So if you know what that side slope is and you know approximately how far it goes down to what elevation, so like in this case, it's somewhere around, I estimated it, it's lower than 30 at like 427. So if I say it starts at where my abutment is and then it goes down to here, it calculates this other station for you. So I just set up something because we need these a lot on a lot of our bridges. And then I've got it to where you would, but not all bridges have them. So I didn't want it to be directly mapped into this graph, but like see this graph right now has the sloping abutments in the wrong location. But off to the side, I had done the math to put them in the right location. And so see, it puts them right there. It basically just calculates them like that. So if we were to add this data into the model to make your bridge look complete, you would go to your sloping abutment option here. And I would copy that. This is the left one. And so let me go through that one. So when you think about it, you've got an upstream and downstream side to your bridge, and you have basically a left abutment and a right abutment usually. So this is for everything that's on the left side, both upstream and downstream. In my abutment editor, I'm gonna copy it in like that. And then it should pop up like this, something like that. And then on your right side, I'm gonna enter this stuff in. And this stuff is all just like an approximation. You just kind of, what the slopes are, where this point is here, and there is a sloping abutment. So you just kind of throw something in the model, do the math, what elevations it approximately goes to. So you basically just do the math to where you can be able to add this stuff into your model. So I'm going to add one more, which is going to be my right abutment, and copy that there, and then hit OK. And it doesn't really show up much on the right side. It's probably covered by the cross section, but on the downstream side it does. On the downstream side, you see it's sloping abutment number 2. 727.61. Did that make sense? Hopefully it gives you a feel of it's a whole lot of geometry, and I have no doubt y'all can all figure out the geometry, but I wanted y'all to get a feel of where things get entered in there in building a model. And we did pretty much everything that would go into a bridge other than ineffective areas. I am kind of surprised at this one. I thought this would.
I only got one abutment.
Yeah, me too. Only one shows. A lot of times, if it's showing, like if. Let me check that again. Let me
Where's
check
your
the math
downstream
there.
data?
594.
Is that correct? Is that downstream data right? 5. Oh, I thought it was way off. Never mind. Let me copy it.
Let me see. 12. So 1198. 1339. It's downstream. No, the downstream does not look correct on that one. So I would, yeah, I think I hadn't. Upstream, oh wait, upstream left, upstream right, downstream left, downstream right. You know what? I forgot about this. This is gonna make it all the difference. So it actually should be paste values for half of it. And I need to change this in how I set this up, but really your downstream left becomes the other half of this as far as HEC RAS wants to see it. So it would look like that in the model. Because I have these set up to be upstream left, upstream right, but HEC RAS is looking at it upstream one and downstream the other. So it would be really this on the other side for my right abutment. And downstream right would be over here. And that may have been confusing, but it's because when I set this up, I was thinking upstream this side, upstream that side, but really how you enter it in is you enter both upstream and downstream in at the same time for each one. So it's like that. I had it organized wrong is what I'm saying. So it shouldn't really be upstream left, upstream right. It should be upstream left, downstream left. Upstream, and then this should be upstream right, downstream right, like that. and then it'll look correct in your model. But there's usually more time. I had to really rush through this stuff. It is a lot. I mean, HEC RAS is not complicated, but it's a lot of geometry, and a lot of my time is just getting this stuff, doing the math to set where these abutments go and set where the piers go and stuff like that. I don't want to downplay the difficulty of that, but it's not difficult, but it is a lot of geometry to enter into each model. Okay, how much of that could y'all follow? Did y'all get a bridge into your model?
I got a bridge, no side slopes.
No side slopes, but you saw what I did.
Yeah, no abutment, but I got a bridge and piers.
Alrighty, you feel like you could do it?
If I sit for like a day.
Jonathan shaking his head. What about you, Tamara?
Wait, let me see. I'm trying to update the. I think I follow it, and I got two abutments, so I'm good.
You got 2 abutments? Oh, go
You
back.
got it.
Can I see?
It was just like, it was like the way that the calculations is on the right is like the opposites of what we have to put. So I kind of follow that.
Yeah, I need to reformat how I have it in the spreadsheet, because I originally was thinking it was you do the upstream left and downstream left, but it's really, I was thinking you do the upstream left, upstream right, downstream left, downstream right, but HEC RAS wants to see upstream and downstream of the same, of like
Yeah,
this
it
one,
says it
and then
in the
upstream and downstream of that one.
yeah, in the window says upstream and downstream. It doesn't say upstream.
Yeah. Yeah, the other thing, so we talked about ineffective a little bit, and I'll give you a brief run through. So the other thing, what I do in my DGN is draw in these based on their contraction and expansion, where I will have ineffective. Let me just briefly go through what that would, save that one. And then I'll let y'all go, because this took an hour. So this is my, so with that, just as an introduction, we'll probably do this in one of our exercises, but then you saw how you can measure out to what station things will be at. So if I know that this kind of expands at a 2-to-1 as far as contraction goes, or expansion goes, then I can start kind of drawing in my areas that are ineffective, and that with the turns of the stream, you kind of reorient it. So now it's going 2 that way, about 1 that way. And so we get approximately where these lines would be for ineffective. And then you actually enter in those stations. And then the elevations we talked about. So you could, what you need to know is you could have multiple ineffectives. And like for this one, let's look at each bridge at Wood Springs Road. Near that culvert, it's going to be lower. It's going to be this road elevation. And this makes me actually think I did this one wrong. I need to look back at it. But near the bridge, you're going to have the ones coming from that at a higher elevation. When it comes to overtopping this bridge, it's going to be, yeah, it's ineffective till it gets here. But then you get a culvert, it's ineffective in this range as it's contracting to go in there until it gets to here. And then you see like the larger storm, they're trying to get through the main bridge. their ineffective is being controlled by that opening and it's at a higher elevation. So that all can be geometrically drawn into your plan file, and that helps you go in and then just enter those stations and elevations and go. It's probably a little bit confusing as I'm describing it, but as long as you see the concept of the expansion and contraction and kind of estimating where that would be with these lines and then going out and measuring and entering them. Once you do it once or twice, you would get the hang of it. That's all we got for today. Hopefully that was beneficial to y'all. And y'all feel a little more comfortable entering bridges in. So we will. Oh, really? Well, I can show you some one-on-one, Jonathan, to catch you up a little bit. But I'm going to cancel the one for tomorrow and postpone it to next week because we have a new guy starting in Longview that they're taking out to lunch and stuff. So I'm going to try to make that.
Free food, gotcha.
Yes. Alrighty. Well, thanks for joining in, y'all. Have a good rest of your day.
Thank you too.
Dude.
We'll see ya.
Thank you.
Bye.